Good day, students. Welcome to mathcodeserve.com. In this group, we're going to be going over problem number 3 on our Unit 4 test, testing application of derivatives. So we're going to be focusing on points of inflection on this tutorial. Okay, so for question number 3, we're to find the points of inflection of the function f of x equals sine x on the intervals 0 to 3 pi over 2. Okay, so before we get started, let's go ahead and go over how to find the points of inflection. Um, so x is a point of inflection, the x coordinate, of course. The point of inflection is something happens. It is a point of inflection if f double prime of x changes sign. Okay, changes sign. Either from positive to negative or from negative to positive. So if the second derivative changes sign on a particular x value, then that indicates that it's a point of inflection. Alright, so what we're going to do here is find what the second derivative is. Set it equal to 0. That tells us when it's neither positive nor negative. And then use those values to create our boundaries for the intervals where f double prime is either positive or negative. Alright, let's go ahead and find the first derivative first. So our function is sine x. The first derivative, f prime of x, is equal to cosine x. The second derivative of f is negative sine x. Okay, so we're going to solve for where this function is equal to 0. That will be our boundary points. So if you solve this equation, we have sine x equals 0 divided both sides by negative. And when is sine x equal to 0? So the solution to this equation, when is sine x equals 0? We know that sine x is equal to 0 whenever x is an integer multiple of pi. So in this restricted interval right here, the solution is going to be 0 and pi. Okay, so solution, the general solution to this equation is x is equal to n pi, where n is an integer. Okay, another way you can write this is you can say x is equal to 0 plus or minus pi plus or minus 2 pi, and then the pattern goes on and on. Okay, but you can clearly see that from 0 to 3 over 2 pi, or 1.5 pi, only 0 and pi are solutions. Okay, so x is equal to 0 and pi in the interval, on the interval 0, 3 pi over 2. Okay, so just to give you a visual, this is a graph of the second derivative. So the graph of the second derivative, we're going from 0 to 3 pi over 2. So let's call this pi over 2. Call this pi. And then right here, 3 pi over 2. Okay, so graphing negative sign, or we can graph positive sign, is the same thing. Let's graph the second derivative just to be precise. So we're graphing negative sign, right? So negative sign starting from the center, go to the minimum, back to the center, and then to the maximum. Okay, so this right here is a graph of the second derivative, just a sketch. Okay, so this is f double prime of x. Now when is it equal to 0? You can clearly see that the second derivative is equal to 0 at 0 and pi. Okay, now we're looking for where it's concave up and concave down. So what we're looking for is the sine of the second derivative. All right, so we're going from 0 to pi, and then 3 pi over 2. What's happening here is one of the endpoints happens to be a point where the second derivative is 0 also. Okay, so we have an overlap in this endpoint right here. Okay, all right, so what's the sign of f double prime on interval 1 and 2? Well, the nice thing about this problem is we have a visual here. We have the graph of the second derivative. So we can easily tell that between 0 and pi, the second derivative is negative, and between pi and 3 pi over 2, the second derivative is positive. All right? So those are the signs of f double prime. So sign of f double prime. What does the second derivative tell us about the function itself? It tells us where it's concave up or concave down. From 0 to pi, second derivative is negative, which means the function is concave down on this interval, and concave up from pi to 3 pi over 2. Okay, so let's go ahead and write it down. The function the function is actually, we're not asked to find where it's concave up or concave down. We're asked to find points of inflection, okay? So we don't have to state this. So let's go ahead and state what the points of inflection are. Since concavity changes at pi, then that's a point of inflection, okay? So we can either say concavity or the sine of the second derivative. Let's talk about use the sine of the second derivative, all right? So since f double prime changes from from negative to positive, from negative to positive on pi, from negative to positive, you can say negative to positive or from concave down to concave up. Talking about the concavities as effective as talking about the sine of the second derivative. So since f double prime changes from negative to positive at x equals pi, there is a point of inflection at that point at x equals pi. All right, so when you're looking for a point of inflection, you're not looking for when the second derivative is 0. That's a necessary condition, but it's not sufficient. There must be a sign change. We have to show that the sign changes about that point to clearly conclude that that is a point of inflection. Okay, so this value right here is a POI, point of inflection, because of the change in concavity. Thanks so much for taking the time to watch this presentation. We really appreciate it. Feel free to post any comments or questions that you have about this video in the comment section below this video. If you have if you'd like to request any videos, feel free to include it there also. Feel free to subscribe to our channel for updates to other cool tutorials such as this. Thanks again for watching, and have a wonderful day.